Good morning. So we are going to be talking about what happens when we get that undefined when we're doing our quadratic formula. And that has to do with imaginary numbers. So we're used to working with real numbers. So like numbers we can like buy things with, like we have $5, things like that. So imaginary numbers are useful in the complex world of mathematics, and they are shown by the symbol I. So I make my I a little curly just so you can tell it's an I. So this is the symbol for imaginary. And there's a couple things about the I that we need to know. So I means the square root of -1. Some other properties of I is if we have I squared, that actually means -1. If we have I cubed, that's -I, and I to the 4th power is a +1. So these are just some things about imaginary numbers. So if you have an imaginary number and an imaginary number squared, it will give you this -1. So why does this matter when we're working with our quadratic formula? Well, let's see how we simplify with it. So say, for example, we had the square root of -9. If we put it in our calculator, it's going to say undefined. But we can simplify this knowing what we know. We have this negative in front, so we know that's like the square root of -1. And then we know the number we have is 9. If we look up here, I is the square root of -1. And we know what the square root of 9 is. It's 3, because 3 times 3 gives us that 9. So the square root of -9 simplifies into 3i. So this is an imaginary number. This is what this simplifies to. Let's look at another one. Say we had the square root of -16. We can do the same thing. We can break it up. So we have that negative, so we have that square root of -1, and then our number is 16. So the square root of -1 is I, and we know the square root of 16 is 4. So our answer is 4i. That's our simplified form of -16. Let's look at one more that's a little trickier. Say we had the square root of -7. All right, we have the -1, and we have the square root of 7. I know the square root of -1 is I, but I don't know the square root of 7. And that's okay. I can just rewrite it because I don't actually know that number. It's going to be an ugly number with all those decimals, and we don't need to know that. And the way we would write this is we would have I root 7. If you write it as root 7i, that's okay too. I just like, it might be easier to start to do it with the I in front, because when you're plugging it into your Desmos, sometimes that I can get trapped under the square root symbol, and you don't want that. So that's simplification of these imaginary numbers. But why does this I squared and I to the 4th and I to the 3rd matter? Well, that matters when we do multiplication. So we can multiply our imaginary numbers just like we can multiply our variables, just like we can multiply our regular numbers. So say we had 2i times 7i. It looks really daunting, but we can multiply what we know first. So I know 2 and I know 7. And 2 times 7 will give me 14. Now I have an I and an I. And that I times I will give me I squared. Just like if you do x times x and it gives you x squared, same thing happens for these imaginary numbers. Well, if I look back up here, I squared is the same thing as -1. So I would replace my I squared with -1. And 14 times -1 would give me -14. So 2i times 7i is actually -14. It's really weird. And when you get into more complex math, you'll be able to see why does this visually and graphically and work, why does it work? Let's do one more with multiplication. Then we'll see how does this apply to our quadratic formula. So let's do -4i times 5i. Again, I know how to do -4 times 5. That'll give me -20, because that's just my normal math. Then I have I times I, which would give me that I squared. Again, we know from up here from our facts that I squared is the same thing as -1. So instead of writing that I squared, I'm going to write -1. And I have -20 times -1, which gives me 20. So multiplication, the only big difference that is kind of new is this imaginary I squared being -1. Why does this matter? Why do I care? Well, let's go down with our quadratic. And let's say we're working with y equals 3x squared plus 5x plus 6. We're going to do everything that we normally do. So our first step, we find our a, our b, and our c. So my a is 3, my b is 5, and my c is 6. And I'm going to plug it into the quadratic formula. All of this we're really good at so far. So I have -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. We're used to being able to be like, cool, I can put this in my calculator. It will give me my answer. But when we're working with these imaginary numbers, that's when we got our undefined. So we have to take a step back and do some of the simplification on our own. So our first step was to figure out what a and b is. Our second step was to plug it in. Our third step is to simplify. So -5, I can't simplify that any. Plus or minus 5 squared, I can simplify that. I know that's 25. And then I have -4 times 3 times 6. And I can simplify that. -4 times 3 times 6 would give me -72. Then all over 2 times 3, I can simplify that. That's 6. So we identified, we plugged in, and we simplified. Our next step to simplify further is we just subtract. So I would have -5 plus or minus the square root. When you subtract this, you would get -47 all over 6. This -47, we're going to do like what we are doing up here to simplify, because we can change this into our imaginary number. So I'm going to have that square root of -1 and the square root of 47. I know the square root of -1 gives me that I. I don't know the square root of 47 though, so I would just keep it the square root of 47. Now the last step is trickier than you might think, and it's just to rewrite it. So you want to keep your -5 plus or minus. Instead of putting the square root of -47, we would put I square roots of 47 all over 6. So this is our final answer. This is our unreal or our complex solution to our quadratic. We're going to be doing a lot more practice with this. So if you're still a little stuck, make sure you're asking questions, but you got this.